come on guys, let's do this sweet differentiation. It says y is equals to x to the power of x to the power of x to the power of x, and so on till infinity, like forever. And it says we should find dy dx. This is interesting, right? So solution. It says we should find dy dx. But I would love to make it easier for myself by saying this whole x, starting from this, should be some values. I will say let x to the power of x to the power of x and so on equals to k equals to p equals to p. Let's not use k. Equals to p. So I can rewrite the equation as y equals to x to the p. But you should notice something. If x to the x to the x and so on is equals to p, remember y is equals to x to the x to the x and so on. This actually goes to infinity, and this one as well, starting from the second one, also went to infinity. That is the interesting thing about infinity. Even when I remove one x from it, it is also going to infinity. And if it is going to infinity, removing one x from it shouldn't affect it. So I can as well say that our p is equals to y. Yes. So I can write this as, this implies that y is equals to x to the y. Now we can easily differentiate this, right? So differentiating this, I would say by logging both sides with the natural logarithm, this is ln y equals to y ln x. Differentiating this in respect to y. Differentiating ln y in respect to y is 1 over y. But don't forget to put your dy equals to, differentiating this in respect to y, first we have ln x, then our dy. We are differentiating this with what is called the product rule. It says we differentiate this first with respect to y and multiply with this, and we add and differentiate this in respect to x, multiply with this. So differentiating y is 1. 1 times this is this, then your dy. Then adding, you differentiate this, which is 1 over x times this, which is y. But don't forget the x, since you are differentiating in x. So now we can simplify. We isolate those with dy. So this is dy minus ln x dy equals to y over x dx. So I can say 1 over y minus ln x dy is equals to y over x dx. So now dividing through by dx and simultaneously dividing through by this, I would have my dy dx to be equals to y over x over 1 over x and y minus ln x. So I can simplify this further. This implies that dy dx is equals to y over x in bracket 1 minus y ln x over y. Do that in your own time. Try to simplify this further. So with this, I have my dy dx to be equals to what? To be equals to y squared over x minus xy ln x. But remember, our y was x to the x to the x to the x and so on to infinity. So we can actually replace it here, and we'll say this is equals to x to the x to the x and so on multiplied by x to the x to the x. That is the of y squared. Y times y to y squared. This is the answer to the question.